Okay, it's a recording. Okay. So we already started talking about example 3. The sphere had a radius of 8 and a height full of oil. And something that I want to make sure comes across clearly is that as we slice through this circle, what is each slice going to be? Each horizontal slice? A circle. A circle whose radius, every circle, its radius is going to be changing with respect to the green circle I just highlighted. So its radius is actually this horizontal distance that's traveling from 0, 0. So each one of these little slices, its radius in our pi r squared situation is going to be changing with respect to that green, like front-facing circle. So then let's write the equation for this front-facing circle. If the radius is 8, then we have a center at 0, 8, and radius is 8. Let's fill it in. We got x minus 8. No, we don't. We got x squared times y minus 8 equals 64. So again, our cross sections are all going to be these little circles. The horizontal slices we're cutting through are circles. So we need to find the little area of each slice of the circle. And we're saying that the radius of each slice of the circle is like relative to this equation we just wrote. So if we're plugging into pi r squared, do you think I need to solve for x, or can I just solve for x squared? If x, right, because x is equal to r, so that means that x squared is equal to r squared. So in our area formula, area of a circle, pi r squared, we're now going to have pi x squared. So whatever distance I had to travel horizontally on that green outer circle will be our radius of each slice. And remember, your volume is taking your area and multiplying it by the change in height, because we're trying to pump water out of this tank and we're pumping it changing vertically. So if I said pi x squared change in y, does that make sense? Yeah, but like, is that going to integrate well? No, so what should we do? Yes, change the x to be in terms of y on the circle. So we have x squared is equal to 64 minus y minus 8 squared. Okay, subbing in. You do not need to simplify the y minus 8 squared. You can, but you don't need to. And remember, we're taking each one of these little volumes. Our forcing equation is taking the volume times our density. And when we integrate it, we're going to be adding up. Our work is going to be taking the sum of all those forces, which is going to become times change in y. So when we go from a sum to an integral, what does the change in y change to? dy. So anywhere you see a delta y is eventually going to become a dy. It's just changing from adding up notation, delta y, to a dy integral notation. This is essentially dy. All right, so our force is equal to our volume times the density of the liquid. What's the density of the liquid in this case? 50 pounds per cubic feet. This is the density. Or rho, if you know your Greek letters. So we got volume. What units is volume in? Feet cubed. Because even if you go back to your elementary school definition of volume, you got length in feet times width, feet times height, feet. So you got feet times feet times feet. So volume is feet cubed. So we have our volume thing in feet cubed times our 50 pounds per feet cubed. And now we're in a force unit, which is pounds. If we're in meters, we need to be in newtons, which we need to multiply by gravity. We'll talk about that before we do the classwork. Okay, so let's go over here. To go from force to work, we need to do a couple things. We need to figure out where the pump has been displaced from. So we're multiplying by the distance to the pump spot. We started out at 0. And where is the pump at? Through a hole at the top of the tank. So how high up is the pump? 16 feet. So remember, the liquid is full in this tank. Or we have liquid. As we drain out the liquid, we are getting lower and lower into the tank. So as we drain out the liquid, if we're saying 0 is at the bottom and we're moving up y amount, how much would we actually care about? 16 minus y. I've learned I need to make sure I put a tail on my y so that people don't think it's a 4. Hi. Oh, yeah, sorry. My problem was I don't know his name. I know what's his first name.
Samuel.
Okay. Is it M-I-C-K?
Yeah.
Okay. I was like, yeah, I'll send it to you. And then I was like, I don't know what your name is.
And he was a dog, so I didn't know if he was.
I didn't hear it at all.
Do you know Mussolino's?
No.
Since you've given her a gift.
No. I know I'm so antisocial. I just kind of like say my little bubble.
I thought you made a friend and then you said nope.
Her first name is Miss. All right, what are the bounds gonna be? The bounds in all work problems are where we're trying to displace the object or whatever we're moving to and from. So the object we're moving is the liquid. So the bounds are gonna be the liquid start and stop. Okay, so the bounds here, Colin, what are the bounds gonna be?
0 and 16.
0 to 16, because it was full. Oh wait, was it full? Or was it half full? Oh, it does say half full. Would you look at that? 8, because it was half full. And then we did the work until it was emptied. And I'm going to write my whole equation. So we got the 50 from the density. Pi radius was 64 minus y minus 8 squared. And then our pumping location, 16 minus y dy. The most common mistake is mixing up the pumping location and where the liquid is. The pump, it has to be part of the equation of work because it's literally like part of the effort is to get it up to that spot at 16 or whatever it is in that case. Okay, thinking about Example 3 versus example 4. So example 3 is a sphere. Example 4 is like essentially a cylinder turned on its side. So similar but different. I think example 3 is really hard. But I think example 4 is the most commonly screwed up type of this work problem. Save the best for last, you know. So the axis, we got horizontal. This is most likely how tanks filled with like gas or oil are going to be stored. Up north where they like heat their houses with gas, most people have like a gas tank just like sitting next to their house if they don't get city gas. And so then they have these like tanks that look just like that right next to their house, and then they have to get filled every once in a while. Sometimes they bury them, whatever. So anywho, but then the ground freezes. It's a whole thing. Northern living, I wouldn't know anything about it. So in example 4, we got the diameter is 5 and the length is 12 respectively. So diameter is 5. So at its widest point, we got 5. It's not straightening out. Okay. Widest point is 5. And then its length, connecting the two parallel faces, is 12. If I did an aerial view of this, so I'm just like looking over this tank, what shape am I gonna see? A rectangle. Not a square, because squares mean sides are equal. And not a circle, because I can't see that side being a circle. I'm looking at the top of this tank, and all I'm really gonna see, the shape that they're gonna dig out of the ground is gonna be a rectangle if they're gonna try to bury this. So the aerial cross section is a rectangle. And this is the part that people mess up. They're like, oh, I see circle, pi r squared. No, the slices, when I slice through this shape horizontally, I'm going to be slicing, like think of like taking a knife. If I took a knife and I sliced through it, what shape would I get? Each time I'd slice a rectangle out. So that's the areas that I have to accumulate. Now, as I slice through this rectangle, is my diameter changing? Yes, this part is smaller at the top than it is in the middle. And then it gets wider again near the bottom, and then it starts getting narrow again. So the diameter is changing, or the width is changing. Is the length changing? No. So our length is always going to be 12 times whatever the diameter is. And how the diameter is changing based on the height. And how is it changing based on the, like, y? Is it changing on a line, or is it changing on a circle? Is that a parabola? Never. Never going to be a parabola. Spoiler alert. Never a parabola. So as we go through, let's say this is my diameter at this height. Then we have our diameter over here. It's getting wider the deeper we are. And then it starts getting narrower again along the circle. So it is changing with like the change in our radius, or change in our diameter is changing with respect to the depth. And our depth is y. The relationship between the radius, and I want the radius because it's changing on a circle. I want it to be radius and not diameter because like that's a lot more simple to deal with the equation of a circle with our radius. Between the radius and the y is a circle. You can tell the shape by looking at it from like the front shot. So we have 12. What's the relationship between diameter and radius? Diameter is equal to 2r. So really our area is going to be 24r. And we're saying that our r is dependent on our y. R is depending on y, and that dependent relationship is on a circle. So we need to write the equation of a circle. Let's draw things. Okay, so where is the center of this circle? So this is the circle we're talking about. Where is the center of the circle? Not 0, 5. 0, 2.5. If I'm saying this is 0, 0, we got 0, 2.5. And what's the top going to be? 0, 5. Find the work done to pump the entire contents of the tank to a height 3 feet above the tank. So if we're here at 0, then we're at 5. That's where the liquid is. And then the pump is 3 feet above. How high is the pump actually from the ground? 8 feet. So we're going 3 feet above 5. Okay, let's write the equation on the circle. We got center at 0, 2.5. Radius, 2.5. And I intentionally am putting my origin at like the bottom and not somewhere to the left of it, so that I'm not going to have like x minus 2.5. Like we don't want to have the center. We don't want x to not be at 0. Like, so you can put the origin wherever you want. It's just like wherever you decide the origin is going to be, but put it in a place that makes your life easy would be my suggestion. X squared plus y minus 2.5 squared equals 2.5 squared. Fun fact about me, I really don't like decimals, especially squaring decimals, because I screw up decimal places a lot. So what is 2.5 equal to in fractions? 5 halves. So then 2.5 squared is going to be, yes, so much better. And most definitely less likely for me to forget to bring that square everywhere I put the 2.5. Okay, so then looking at my area formula. My area formula is 24R. And we're saying that every point along this curve is some, like, we're slicing through some radius amount of this yellow circle. So do I need to solve for x or for x squared here? So let's look back. Look at our area in the last problem. What was our area formula in the last problem? Pi r squared. So we solved for x squared because in the area problem, we needed pi r squared. So we need x squared. Now we need 24r. And we're saying that x is equal to r. So we need to get x. So solving for x, I'm going to get x squared equals 25 over 4 minus y minus 2.5 squared. When I square root both sides, I have been doing plus and minus. But this is representing a radius, so it's always going to be positive. Radiuses are always positive. They're lengths. They're like distances that you needed to travel. Eventually, they'll be vectors. So we got our area formula is 24 times the square root of 25 over 4 minus y minus 2.5 squared. How are we going to make this be a volume? Yeah, multiply by delta y. And then our force, what was we're doing, what, gas? So our force becomes 42 times 24, all this stuff. All right, and try to beat me to writing your work expression. Think about where the pump is versus where the liquid is. All right, when our liquid was getting emptied out, so we should have 0, and it was completely full, what should the top boundary be? 5. It's not where the top boundary is not where the pump it's pumping to. It's where like we're moving this water to and from. Okay, let's ask questions about these two, because I promise if you are confused, someone else is confused. Let's ask our question. Yeah. The 42, so when we go from force to work, we have to multiply by the pump spot, which was where that 8 minus y came from. And we have the 42. Oh, that's what you asked me. 42 is the force is equal to volume times the density of whatever the liquid is, which our liquid was gasoline, which was 42 pounds per cubic foot. And then we also have to have the boundaries correct for our liquid. So this is different than what we did last class. I know someone was absent last class, so I just want to remind us. Last class, how was the radius changing with respect to y? On a line. So sometimes in your work equation, even though we're slicing through this one, pi r squared, we had a linear relationship between the radius and the y, versus on example 3, we had a still pi r squared, but then we had a circular relationship between how that r was changing with respect to the depth. Yep.
So if it's changing on the line, are the boundaries from the origin to the pump?
Nope, the boundaries are always where the liquid is. This is changing what our radius equation was. Where the pump is and like the relationship between our width and our y is always part of like the actual function. So remember, we saw the cross section was pi r squared, and then we were like, okay, we have to figure out if the volume is pi r squared change in y, then we need to get that pi x squared, because x is really like the horizontal displacement we were doing. We need this to be in terms of y. So then getting that in terms of y, we were like, oh, when it's full at the top, there's 15 feet of y, and 15, oops, I put y, that should be a t, 5 feet in the x. And then we figured out like the relationship between x and y, and then plugged that in to where r was in your area equation. Okay, one more thing that I wanted to bring your attention to for the classwork before we get going, like the awesome people you are. Oh, hello. I forgot how laggy this gets when I'm still recording. So we got, we're going to be doing the back page. The density of water is 62.5 pounds per cubic feet. But if we're in meters and kilograms, we need to multiply by 9,800. That'll make it become newtons. So this is if we're in meters. So instead of multiplying by 62.5, you're multiplying by 9,800. So 4 and 6 are going to be multiplying by 9,800 because you see how it has an M? It's going to be 9,800. It's a different, like the density of water is actually 100 kilograms per cubic meter, but then you have to multiply by gravity. Obviously, the kilograms is not a force. Yeah, it's multiplied by this. We're doing 4 through 6. 4 through 6.
Okay, this is rectangles that are changing linearly. But first, like these edges are like. Aerial cross-section is a rectangle.
Right, but the F is still, F is all.
And HubSpot is 5. The volume of this.
This is changing.
The volume of this like
So our length is constant. Length is always going to be 8. Our width does change.
8 times, and the width is changing. 8 times.
You do have to bend your mind. I realize I did that whole thing without turning. Glad I wore rubber.
So we know it's going to be 8 times what's our rate of speed.
We're doing 4 through 6.
The full height here is 3.
So it's 8 times the rate.